Hello people, I'm Bharat Acharya. Welcome to our new video. So today's video we're going to do 8051 programs on the EdSim simulator. Yes, last week we uploaded one more video like this that was introducing you to the EdSim simulator. Thank you so much for all the lovely messages you sent after that. I know you've been waiting for this. Doing programs on the board, writing programs on paper is one thing. Doing it in practice, implementing it on the simulator like the way you do it in the practical exam is a different thing altogether. So many times people can write perfect programs on paper. But when they're sitting in the practical exam with the examiner standing right behind you, watching everything that you're doing on the screen, there's no chance of looking here and there and trying to manage your way around. At that time, many students fumble, some students just don't bring themselves to the situation where they can write the program. Sometimes it's due to a lack of confidence, sometimes it is just poor preparation, sometimes it's just no exposure to the simulator. Doing everything on paper is good, but the real test is if you can execute that program, make the program run, test under different conditions, different inputs. That's what we're going to do. We did something like this last video also. We're doing it again. But of course, we are moving ahead, more intense programs. What we had done last time was just add, subtract, multiply, divide. Now we're doing all exam questions. The first program that we'll do will be a block transfer. So there'll be a block of data stored somewhere in the memory. You'll copy that block exactly and store it somewhere else. You know where is this program used? The reason why this is a popular question, this is the program that runs in the background when you do copy paste. Come on, we do it so many times in a day. It's a regular thing, Control C, Control V. Or if you're an Apple, Command C, Command V, either way. So what you do is you select a block of data, you press copy, you go somewhere else, you press paste. What happens in the background is the program that we're going to do, not only on paper, but also on implementation. I will store a series of numbers, we'll run our program and we'll see whether the entire series has been copied to a different place or not. The next program will be a slight modification of this question. This is called inverted block transfer. Inverted block transfer or block reversal, string reversal, however you want to call it. There'll be a block of data, let's say 1, 2, 3, 4, 5. It should be copied, but not as it is. It should be inverted and copied. So 1, 2, 3, 4, 5 should become 5, 4, 3, 2, 1. That's basically, it's a prelude to checking whether a string is a palindrome or not. A forward and the reverse part of the string, if they are compared and they are the same, that means the string is a palindrome. So this is one step before that, the reversal part of the string. Anyway, so that's our second program. Again, we will do it on paper. First, I'll show it to you on paper, then we will implement it. Implement it on the simulator and run it and see whether the block has been inverted or not. The next one, big question, a lot of times asked. Take the last 10 papers of Mumbai University, you'll see it in 2 or maybe 3 times. So that's quite a big probability of it coming again. Which one? Highest number. Finding the highest number. Yes, we have not even made a video of this on the blackboard. Finding the highest number in a given series. So there'll be a series of numbers. It's like, where is this used? You go to Microsoft Excel. I'm sure everybody is familiar with Excel, right? You make a table, let's say, of your marks, subject, marks, subject, marks, subject, marks. You made a whole table. Now, when you select all the marks, on the top, there are predefined functions. The sum of all of them, the average of all of them, the max, there's the button max. When you click on that, right below the series comes the highest. So you come to know which subject you cracked it. Mostly it'll be our subject next semester. Anyway, we're doing the program that runs in the background. When you do that, when you pick up the highest from a series, how do we do it? We'll assume a number to be the highest. We'll compare it with every number till the time a new higher number is found. As soon as we find a new higher number, we'll copy it, blah, blah, blah. Of course, I'm going to teach you. We're going to dry run it on paper with a few numerical examples. We'll load it on the simulator. We will write a series of numbers and then run the program and see whether every time it picks up the highest number or not. And with a minor tweak to the program, we can even pick up the lowest in the series, the max and the min, 2 standard functions. The last program that we'll do today will be the most intense program I have taught you in 8051 so far. That will be sorting. Another very popular question. From real world point of view also, you need it all the time. You sort when you're shopping sort on lowest price first, highest price first, max discount first, etc. So when you click that button, the program that runs in the background that sorts all the elements, that's the program that we're going to be running. There are numerous sorting algorithms. You can use any algorithm you want. The most popular one amongst the students is bubble sort. So we'll also be doing a program using bubble sort. First, I'll explain to you the whole sorting on paper with diagrams. This is your original series. What happens when you do the first iteration, then the next iteration, then the next iteration, and this is where you stop, where you get your final series. I'm going to show it to you on paper. We'll write the program first, try run it with a few numbers and see whether it works or not on paper. Then implement it on the machine, on the simulator, enter a few numbers, run the program, it should sort it, we will test it, what happens if the numbers are same, etc. and so on. And then with a small twist, a minor tweak of the program, we'll be able to sort it in descending order. Once you know how to sort it in ascending order, same program will work for descending with a small twist. Anyway, so these are the 4 programs that we're going to do. Okay, people. So our first program is to transfer a block of data. It's called a typical block transfer program. The source block will be stored somewhere. You want to copy it, exactly paste it into our destination block. Clear? Let's say. So every program that we do, I'm going to first make a logic diagram, understand the logic diagram, understand the code, and then we implement it. Come on, let's start. So location 20 to 29. How many locations are these? 10. Correct. This block has to be transferred from location 30 to 39. These are 10 locations. So this entire block should be repeated over here, copied and pasted over here. Are you clear? How are you going to do it? Take the data from location 20 into a register like A, store it at location 30. This is 1 byte. Now put this process in a loop and do the loop 10 times. So for that, there has to be a count. We will keep the count in a register like R7. We have kept a count of 10 in a register like R7. Are you clear? So that's your count. Every iteration will decrement R7 and will break the loop till R7 when R7 becomes 0. So you get, so you given a count of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. You'll get exact 10 iterations. Are you clear? Now, since we're going to use indirect addressing mode, since we're going to make a loop, we will use 2 pointer registers, R0 and R1. R0 will point to the source, R1 will point to the destination. So I will initialize R0 with the value 20, initialize R1 with the value 30, initialize R7 with the value 10. Take the data pointed by R0 into a register like A. Store A at the location pointed by R1. Increment R0 so that next time it points to 21. Increment R1 so that next time it points to 31. Decrement R7 so that next time count becomes 9. Put the process in a loop. So first time you'll transfer from 20 to 30, 21 to 31, 22 to 32, 23 to 33, blah, 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 10 iterations, 29 to 39. 10 iterations are over, your block is transferred. That's your program logic. Tell me, did you understand? Now, let's do the coding. First of all, I will initialize R0, R1 and R7. Move R0, comma, hash 20. So R0 is your pointer to the source. Move R1, comma, hash 30, pointer to the destination. R7, comma, hash 0A. That is your count. Are you clear? Source pointer, destination pointer, and count. Now, take the data pointed by R0 into A. Move A, comma, at the rate R0. You understand what's the meaning of at the rate R0, right? A gets the data from the location pointed by R0. Store that data from A to the location pointed by R1. Tell me the instruction. Come on. Tell me the instruction by yourself. Store from A to the location pointed by R1. Move at the rate R1, comma, A. Correct. You always write the destination first. So earlier I wanted from memory into A. Now I want to store from A to a memory. So move at the rate R1, comma, A. So the data we got from the location pointed by R0 into A, that data now we are storing at the location pointed by R1. In simple terms, we took the data from location 20 into A. From A, we are storing it at location 30. One iteration, one job done. Next iteration, you want them to point to the next location. So increment R0, increment R1. The instruction that makes a loop is DJNZ. I'm sure everybody is familiar with DJNZ. DJNZ stands for decrement and jump if not 0. It will decrement R7, and as long as it is not 0, it will jump to the location back. Back is here. So first time R7 was 10, it will become 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It will give you 10 iterations and your block is transferred. End the program by writing S jump here, jump back to the same location. Tell me, did you understand the block transfer program? Now, we will implement it on the computer. This is your EdSim simulator. Our first program is to do a block transfer of 10 bytes from location 20 to location 30. So now if you notice, location 20 to 29 are 10 locations where I have already stored some data. I hope you can see that. The data values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. What we're going to do is we're going to run our program. This block should be transferred from location 30 to 39. 30 to 39 as of now contain all zeros. They should contain exactly the same data that is there from location 20 to 29. Correct? Now, we've just discussed the program on paper. I'm going to load that program, already pre-written it because I don't want to waste time in typing a program. I'm sure you're not interested in seeing how I type a program. Your interest is to see how the program executes. It's the exact same program that we had written. Start, move R0, #20, etc. Come on, give me the comments. Instead of me writing the program, I thought if I write the comments with you, that'll actually make more sense because it'll help you build logic. So R0 is your source pointer. R1 is your destination pointer. And R7, 10 is your count of 10. Now, take the data pointed by the source. So this is basically take data, store data at the destination, increment source address, increment destination address, and this is your loop R7 times. That's it. We are ready. Always save your program. Always. Yeah, we'll read this. We added a comment. Save. Always save your program. You don't want to lose all your effort. Also, if you find the screen too small to type, there's no problem. Click the plus sign. It becomes bigger. If you want even bigger, in second, you can unlock it and now type it on a much bigger screen. Make it comfortable, etc., etc. Whenever you close this, whatever you had typed will anyway come over here. You don't have to do anything extra. So that's just your convenience factor. Anyway, just wanted you to know that. Now, let us run. Observe these locations, 20 to 29. They should be duplicated over here. Let's slow down the speed so that you can see it happening. That should be more fun. Run. 2, 3, 4, 5, 6, 7, 8, 9. Did you see? The entire block got transferred. Of course, you could run it at a much higher speed also. What's the point? If you still want to pause, done. Program done. Now, if you want to test it further, what do you want to do? Transfer from 30 to 40. Say, for example, what difference does it make? 30 to 40. Come on. Change your addresses. Change your addresses. Let's say your source pointer is at 30. Your destination pointer is at 40. Now let's see whether it runs or not. And let's run it at higher speed so that we can directly just jump to the result. Come on. Observe. This is your 30 to 39, your source. This is your destination 40 to 49. Keep your eyes over here. Run. The entire block has been now copied from 40 to 49. Tell me, did you understand this? Now, and so on. You can go on testing it now. Change your count, change your addresses. You can make it work wherever you want in the memory. Say, for example, you want to copy from 25 to 2B, 25 to 2B, 25, 26, 27, 28, 29, 2A, 2B. That's 8. So give you a count of 8. It will copy from 25 to 2B to 35 to 3B or wherever you want to copy, etc. You can change your addresses and run and play with this. You can change the data. If you want to change this data, just go to location 20, type FF, And now like this, go on doing it for all of those locations and then run the program again. It should give you the correct answer every time you run it. Okay. That's it. That was your first one, block transfer program. Hope you enjoyed seeing it. Immediately we'll go to the next one. Okay, people. So our next program, now that we've done a normal block transfer, our next program is to do an inverted block transfer. Whatever was the block, if it was 1, 2, 3, 4, 5, it should be copied the reverse way. It should become 5, 4, 3, 2, 1. It's pretty simple. If you're sharp by now, you would have yourself realized what's going to be the change. So this is your source block, 20 to 29, 10 locations. You want to reverse it, which means the first byte should go to the last location. The second byte should go to the second last, which means this address should go on getting incremented, but this address should go on getting decremented. So, what is the idea? Initialize. Correct. More people try to answer by yourself. Initialize. Yeah, say it. R0 with 20. Correct. Initialize R1 with the last address, 39. Initialize R7 with your count 10, as usual. Take the data pointed by R0 into A, correct? Store it from A to the location pointed by R1, correct? Now, increment R0, but decrement R1, correct? And decrement R7 as usual, and put this in the loop. So what will happen is, first byte will go to the last location, second byte to the second last, and so on. 10 bytes are transferred, your whole block will get inverted. Are you clear? Come on. First tell me in English, then we'll code it. Initialize R0 with 20. Good. Come on, speak up. People around you should know that you're studying. Should come to know you're studying and you should be happy that you are understanding what you're doing. Initialize R0 with the value 20. Initialize R1 with the value 39. Initialize R7 with the value 0A. That's your count of 10. Take the data pointed by R0 into A, correct? Store it at the location pointed by R1. Increment R0. Decrement R1. Decrement R7 and put this in the loop till the time R7 becomes 0. Now, can you dictate the program? Come on. OR0, that's the start. What is the first step? Initialize R0, R1 and R7. Come on, initialize R0, correct. Move R0, comma hash 20, good. Initialize R1, shabash, good. Move R1, comma hash 39. Initialize R7. Move R7, comma hash 0A, good. Now, take the data pointed by R0 into A and store it at the location pointed by R1. Come on, confidently dictate the instructions, confidently. Move, correct. Move A, comma at the rate R0. Next one, move at the rate R1, comma A, good. Increment R0 in decrement R1. Increment R0 but decrement R1. Correct. Decrement R1 and DJNZ R7 comma back. That's your loop. When the loop is over, here is jump here. Program will be done. Are you clear? Let's implement it on the simulator and test it with the numbers, whether it gets inverted or not. Next one. We had seen normal block transfer. Now we'll see inverted block transfer. Again, I have typed the program and kept it ready so that we don't waste time in doing the typing part. This is your data memory. So now location 20 to 20 to 29. Let's say in the data of location 20, let's keep it sensible. Let's say 00. So location 20 to 29 have the value 00 to 09. This should get inverted and come from 30 to 39. So basically the results over here should be 97865432110. Are you clear? Let's see if that happens or not. What is the coding like? R0 will point to the source. So this is the source pointer. This is your destination pointer. This is your count. Take the data from the source. So take data, store data at the destination. Increment source address, decrement destination address, loop R7 times. Let's see. Save your work. And we are ready to run. observe location 30 to 39. It should get inverted. It should be the reverse of 20 to 29. Let us run. That's it. If you observe, the numbers have become 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So your entire block has been inverted and stored over here. Again, you can practice it for any locations. Now, okay people, so now we get into a little more serious program to find the highest in a series of numbers. In computer branch in Mumbai University, this question has come 4 times in the last 10 papers. In computer branch, they do it for 8086. The exam setters are pretty much the same. The teachers are pretty much the same. Microprocessors, microcontrollers, 2 sides of the same coin. So, in my opinion, not only for Mumbai University, whichever university you are in, this is a very important program, okay? And it's a program which is very easy to test in practicals. Examiners will just have a series of numbers. They don't even need to enter. Memory will randomly contain some series of numbers. They'll tell you run the program. Instantly, on the spot, they come to know whether your program is right or not. It should pick up the highest number and store it wherever it is asked to store. So let's say our question is location 20 to 29 are 10 locations. We want to pick up the highest number in this series and store the result at location 30. That's your program question. 20 to 29, 10 locations have different numbers. 5, 7, 20, 3, 9. Tell me out of these which is the highest? 20. That should be picked up and at the end stored at location 30. Tell me first of all, did you understand what we have to do? Can we start coding? Come on. First we'll build the logic, of course. I'm just getting to the right focus. Yeah. Okay. So what's the idea? By now, after doing so many programs, you know if you want to access a series of locations, you need a pointer. So we initialize R0 as our pointer to location 20. You know there is a loop, so there will be a count. So we initialize R7 as our loop count with a count value 0A. So R0 and R7, I may not have written that yet. R7 initialize with the value A, okay, as your count. Now, that's your initialization. We will initialize A register with the value 0, assuming this to be the highest number so far. See, even if the series is all zeros, 0 is the highest number. So A being initialized as 0 is a good default assumption. There are different ways to tackle the program. I'm showing in a way that most students will find easiest to understand. So I'm initializing A with the value 0. A at the end of our program will have the highest number. What is the logic? In the loop, we will go on incrementing R0 so that it points to a new number every time. Are you clear? We will compare A and the number pointed by R0. These two will be compared. Are you clear? If this number pointed by R0 is greater than A, it means we got a new higher number. Did you understand? We'll compare A with every number over here. Every time we get a number which is bigger than A, that means it is a new highest number so far. We will copy. Compare means we are going to do subtraction. Correct? Compare means subtraction. So let's say we will take this number and B. We will compare A and B. Compare A and B means we will do A minus B. If there is a carry, tell me in subtraction, carry means borrow. When is there a borrow in subtraction? When the first number is smaller, the second number is bigger. So if I have done comparison of A and B, there will be a borrow when B is bigger, which means I got a new high number. So if there is a carry, I've got a new high number, I will copy that number into A. Else skip. If there is no carry, then I haven't got a new high number, I will skip it. Tell me, did you understand the logic? Tell me the logic now properly. Who points to every number? R0. You'll initialize R0 at the beginning. You'll initialize A with the value 0. You will take the number, come on, don't get scared. You will take the number pointed by R0 into B. So your two values to be compared are A and B. You will compare A and B. Compare means subtraction. So it will do A minus B. If B is greater, that means you got a new high number. Now, if B is greater, this subtraction will give a borrow, which means it will give a carry. So, if there is a carry, you have a new higher number. Copy that number to A. If there is no carry, skip. Because when will there be no carry? When either A is already greater or A and B are equal. In both cases, A already has the higher number, so I don't need to copy. I only need to copy if there is a carry, because that means B is greater. Tell me, did you understand this? So either I'll copy B to A or I'll skip. Either way, I'm done with this number now. Who was pointing to this number? R0. I will increment R0 so that it points to the next number. Put the process in a loop. Shabash. Come on. Show me over here. You took engineering because you wanted to do programming. This is programming. Come on. Get good at it. You cannot call yourself an engineer if you can't write programs, at least such simple programs. What is this? Finding the highest number should be a piece of cake for you. Come on, look here. Initialize, last time I'm giving the logic, then I'll write the program. Initialize R0 with the value 20. So R0 is pointing to your source, your first number. Initialize A with the value 0, assumed to be the highest number. And initialize R7 with your count of 10. Tell me, are these three clear? Now, the data pointed by R0, that is the current number to be compared. Take that number in B. So you got your number. Compare A and B. Compare means subtract. If there is a carry, that means this is a new high number. Copy B to A. If there is no carry, skip. Done. You're done with the current number. Increment R0 so that it points to the next number. And put the process in a loop. Infinitely? No. In the loop, you'll go on decrementing R7. So you'll be using your DJNZ instruction. The loop will break after 10 iterations. Every time you got a new higher number, you copied it to A. Let's do a dry run. Let's say there are 5 numbers. 5. I'm seeing the mirror image. 5, 7, 20. 5, 7, 23, 9. 5, 7, 23 and 9 are your numbers. Originally A was 0. A will be compared with 5. Is 5 bigger? Yes. A minus 5, 0 minus 5, there is a carry. So 5 will be copied to A. So A will become 5. Next time 5 and 7 will be compared. Yes, 7 is bigger. So A will become 7. 7 and 20 will be compared. Yes, 20 is bigger. A will become 20. 20 and 3 will be compared. No, there will be no carry. 20 minus 3, there is no borrow, no carry. So we will skip, which means A will remain 20. 20 will be compared with 9. Again, no carry. A will remain 20, which means when this program runs, the highest number will be in A, which will be 20. Tell me, did you understand this? Now, that's what we're going to do. Dictate the program to me. Come on, be confident. Come on. Initialize R0, initialize R7, and initialize A. First, tell me this much. Initialize R0, initialize R7, and initialize A. Initialize R0. Move R0, comma hash 20. Move R7, comma hash 10. That is A. And make A 0. That you can do by writing move A, comma hash 0, 0. Or you can write clear A. Whatever you want, it will do the same thing. So that was your initialization. Now, take the number pointed by R0 into a register like B. Move B, comma, at the rate R0. Tell me, did you understand this? B gets the number pointed by R0. Is that clear? Now, clear? Number came in B. You will compare A and B. Now see this fabulous instruction. CJNE, A, comma, B, comma, next. What is CJNE? Compare and jump if not equal. It is basically a compare instruction. Why do we have to do this? Because there is no CMP, no compare instruction in 8051. Comparison is done by subtraction. There are 10 ways of doing the same program. You can do the same thing by writing subtract A and B. When you do subtract A and B, subtract will store the result. So you will lose the value of A. So you'll have to make a backup copy of A, then do subtract A, comma B, then get back the backup. So you'll just be adding more lines to the program, doing the same thing. Instead of that, the correct or the best or most efficient way of doing it is CJNE. It will compare. Compare also does subtraction, but compare doesn't store the result. So it will compare, which means it will do A minus B. Compare and jump A and B. So it will do A minus B, but will not store the result. So neither A will get spoiled nor B will get spoiled. If it will not store the result, how will we come to know what happened? It's a subtraction. So flags will be affected. We will check the carry flag for the borrow. Are you clear? See what I've written. CJNE, A, comma hash, A, comma B, comma next. So compare and jump if not equal. You're comparing whom and whom? A and B. If they are not equal, you will jump to location next. Okay. If they are equal, what will you do? You will not jump. But if you don't jump, what do? You go to the next. If you don't jump, you go to the next location, which means whether they're equal or not equal, either ways you'll come to next. Our purpose is not to jump. We are just using CJNE, but we are not interested in the jump part. Understand one thing. If I say jump to the next location, it's a redundant statement, because even if I don't jump to the next location, I'm anyway going to go to the next location. So when you write CJNE, compare and jump if not equal, whether equal or not equal, both cases I'm going to come to next, because if it's not equal, it will jump to next. If it was equal, it won't jump, but anyway, it will come to next. So the idea is we are not using this as a branch, as a jump. We are basically using this as a compare operation. Whether equal, not equal, doesn't matter. It will anyway come to next. But what it has done is it has compared, which means it has done a subtraction between A and B. It has done A minus B. Tell me, did you understand? So next time you want to do compare in AD 51. What do? Don't write compare. There is no compare instruction. You write CJNE X, Y, next. Where is next? Next will be the next line. So basically you're not doing a jump at all, but you have done a compare. It will compare X and Y, and now check the carry flag to know who was greater, who was smaller. If carry flag is 1, that means there is a borrow. That means the first number was smaller, because it does first number minus second number. So now, when we come to next, we're going to check the carry flag. If there is a carry, what does that mean? If there is a carry, that means A is smaller than B, which means B is a new higher number. It should be copied to A. So for the last time, if there is a carry, I should copy B to A. If there is no carry, that means either A is already bigger than B or A is equal to B. In both cases, I don't need to copy, I need to skip. So if there is a carry, copy B to A. If there is no carry, skip. If there is no carry, jump to the location, skip. Jump if no carry to skip. Are you clear? And if there is a carry, it will not jump. That means it will copy B to A. You can copy B to A. You can copy @R0 to A. Both will do the same thing, because what is at @R0? B. @R0 is the value of B register. You can copy B to A, or you can copy @R0 to A. It will do the same job. Once the number is copied to A, that means A has the new higher number. Now, when you come to skip, either you have copied this to A and come to skip, or you have jumped and come to skip. Either you have got a new higher number which you have copied to A, or you have jumped this and come to skip. Now, basically you have either copied this number to A or you have skipped it. Either way, now you are not interested in this number. Now you want to prepare for the next iteration, which means you need to increment your pointer. So you'll increment R0 and put this process in a loop. Come on, let's run it. Suppose your numbers A originally is 0. Suppose your numbers were 5, 7, 20 and 3. Okay, I've written 4 values, 5, 7, 23. Start. Come on. Move B, @R0. So B gets 5. R0 is your pointer to every number. R0 is pointing the first number. So B gets 5. This is right now @R0. @R0 is 5. Compare A and B. A is 0. 0 minus 5. 0 minus 5, there will be a borrow. So that means there will be a carry. If there is no carry, skip, but there is a carry, so it won't jump. That means A will get the value of @R0. So that means A will now become 5. Are you clear? Now, when I come to skip, increment R0. So R0 is now pointing to 7. Go back. Next time, 5 minus 7. 5 minus 7, there is a carry. So it won't jump, it will copy. So that means A will become 7. Next time, 7 minus 20, there is a carry. A will become 20. Next time, 20 minus 3, there is no carry. It will skip. Are you clear? When this breaks, A will be 20 in this example, which means when this loop breaks, A has the highest number. The question may say store the result after the series. If store the result after the series, anyway R0 was being incremented, it will point to the next location after the series. Store the result directly over here. That is if the question says that. Our question says pick up the highest, store it at location 30. The highest is in A. From A, we will store the result at location 30 by writing move 30h comma A, S jump here. Tell me, did you understand it? Let's implement it. Come on, let's implement it. You'll see it with the numbers. You'll find it even more easy to understand. A third program to find the highest in a series of numbers. I've already written the program. It's the exact same program that we wrote on the board or in the book. I have pre-fed the data. Location 20 to 29 has these values. Okay, I'm going to show them to you. 89, 02, 67, 0, 64, 55, 32, 96, 41, 28. As you can see, out of all of them, 96 is the biggest value. So this is what our result should be. As you know, the result is stored at location 30. Right now, location 30 contains 0. When we run our program, we should get the final result over here. Okay, let us see what happens. I have loaded the program. Before we run it, just give me the comment so that you refresh what's going on. R0 is 20, so that's your source pointer. R7 is 10, that's your count of 10. Clear A, assumed highest number. Take the current number in B, compare A and B. So it will do A minus B, A minus B. If there is a carry, that means B is greater. So B is a new higher number. Then I should be copying that B, which means the current number, into A. When? Only if there is a carry. If there is no carry, that means A is already higher. Skip. So if no carry, skip. Else copy the current number to A. Now when you come to skip, increment R0. So point to the next number. Loop R7 times, that is 10 times. A has the final answer. Store the result. Correct? What do you think? Will it work? Let us see. Save. I've saved the program. Highest number. Yes. And we are ready to run it. Let's reset. Yeah. All flags cleared. Everything cleared. I say again, 89 up to 28. The highest value is 96. It should come at location 30. Let's run. Location 30 has your result. 96. Are you clear? As you can see, location 30 has got your value 96. So it picked up the highest number and stored over there. Now, suppose you want to check for different values. Come over here, enter values, change the series over here, and then run. Instead of 30, you want to store the result at 40. Change the value 40 over here. Instead of the first 10, instead of all 10 numbers, you want to pick up the highest only amongst the first 5 numbers. Give the count as 5 over here, and so on. You can modify your code and run it again and see whether it runs or not and gives you the correct answer or not. Okay? Okay, people. Now, the last one in the series, sorting. Let's do sorting program. So sought after by students, whether it comes in the exam or not doesn't matter. You call yourself an engineer, you shop online every day, you want to know how sorting takes place. When you do sort on price first, highest rating first, things like that. Next time you click that button, you should be able to tell yourself, I know how that sorting took place. I can write the code for that. Come on. Come on. There is a series of 5 numbers. Look here. Stored from location 20 onwards, 20 to 24. There is a series of 5 numbers. They are right now 5, 4, 3, 2, 1, which means they are in descending order. I want them to be in ascending order. Do you understand? I have taken the worst case input. That's the idea. The algorithm is demonstrated the best in when you take the worst case input, because I have to basically rearrange this entire series to eventually reach 1, 2, 3, 4, 5. Correct? Now, come on, let's start. Which algorithm are we going to use? We're going to use bubble sort. Do you remember bubble sort? Compare two adjacent numbers. Say this with me again. Compare two adjacent numbers. If they are in the correct order, leave them. Otherwise, interchange them. That's the algorithm. So simple. If you know the algorithm, you'll be able to understand the program. This is the program for it. Come on, say this once again. Compare two adjacent numbers. If they are in the correct order, leave them as it is. Otherwise, interchange them. Do this over the series again and again and again, and you will get your sorted series. Isn't it a simple algorithm? How difficult it is? I give you 5 numbers over here, I tell you arrange them in the correct order. What do you do? Compare the first and second. Rearrange, rearrange, rearrange. Again stop, rearrange, rearrange. Till the time you got your whole series right. That's what you have to do. Why is it called bubble sort? When next time do the small exercise, when you're washing your hands, which we do very often nowadays. When you're washing your hand, I'm sure there'll be some soap in your hand. Look at your hands at that time. Look at your palm. You will notice bubbles in your hand. Those bubbles will be sorted by nature according to their size. It's a very interesting phenomenon that bubbles exhibit. They bounce off each other till the time they automatically get arranged by their size. The biggest bubble will be in the center, surrounded by the slightly smaller ones, smaller, smaller, smaller. Tiniest one will be at the end. So looking at that, somebody got inspired and created, they just followed good observation of that process, gave this rise to this algorithm. They bounce off each other and automatically fit the space as per their size. So that's why the algorithm is called bubble sort. That was just a piece of knowledge. Now, initialize R0 with the value 20. So R0 is your pointer to location 20. See what we're going to do. Compare two adjacent numbers. So your numbers are 5 and 4. Are they in the correct order? No. Because for ascending, 4 should be up, 5 should be down. Correct? So they are right now not in the correct order. We did compare, which means we did subtract. Correct? Start thinking like a programmer. This is not an English speaking class. Not just in English. You should be able to think of this as how a programmer does. You are doing 5 minus 4. If there is a carry, that means the second number is bigger, the first number is smaller. That means they are in the correct order. So if there is a carry, skip, because you need to do nothing. It means they are in the correct order. If there is no carry, that's when your exchange is required. Tell me, did you understand this? Anyway, so 5 minus 4, there is no carry, which means your 5 is bigger, which means they are in wrong order. Interchange them. So this becomes 4, this becomes 5. I have not written it. This becomes 4, this becomes 5. Correct? Hold on, hang on. Now, repeat the process. When you compared first number and second number, you didn't find them in the correct order, you interchange them. After that, you want to compare third and fourth or second and third. Second and third. You compare first and second, second and third, then third and fourth. Tell me, did you understand this? So, you compared first and second, that is 5 and 4. They were not in the right order. You interchanged them. They became 4 and 5. Now you will compare 5 and 3, the second number and the third number. 5 and 3, 5 and 3, they are not in the correct order. 5 minus 3, there is no carry. They are not in the correct order. 5 is bigger, should have been down. Interchange them. So that means this will become 3, this will become 5. Now you will compare 5 and 2, again not in the correct order. Interchange them. This will become 2, this will become 5. You will compare 5, so this is 5. You will compare 5 and 1, 5 and 1, not in the correct order. Interchange them. This will become 1, this will become 5. So this is your first round. How many comparisons did you do? 1, 2, 3, 4. Why you did 4 comparisons? Because there are 5 numbers. When you have 5 numbers, you compare first and second, second and third, third and fourth, fourth and fifth. You do 4 comparisons. You don't do 5. You do 5 comparisons. You'll compare fifth with a 6, some random number, and depending upon the value of that number will come somewhere in the middle of your series and displace one number out of your series. When the examiner will run the program in practicals and check, the result will be a different series of numbers from what the original numbers were. Are you clear? And obviously the program will fail. So what is the idea? If there are 5 numbers, you do 4 comparisons. If there are 10 numbers, you do 9 comparisons. N-1 comparisons. Are you clear? Now, so you do this in a loop. The count of the loop will be N-1. When you finish your first round, what has happened? Have you got your final answer? No. You got your first series in which the highest number, like a bubble, has bounced off all the numbers and come to its spot. Are you clear? Now, what you will do is repeat the process, which means this program is a loop within a loop. It's a nested loop. Do you understand how a nested loop works? You enter the outer loop, you enter the inner loop, you perform inner loop iterations, inner loop count becomes 0. Go back, reinitialize inner loop count. Decrement the outer loop count, go back, reinitialize the inner loop count. Again come into the inner loop, do all inner loop iterations. Inner loop count becomes 0. Decrement the outer loop count. Go back, reinitialize the inner loop count. Again, so it works like this. Loop, loop, loop. Again all inner loop. Loop, again or inner loop. Are you understanding it? So if you're trying to produce the first series by your inner loop iterations, your first series is over, go back, reinitialize everything. Again, all iterations to perform the second series, then third series, then fourth. So how many such series do you require? Let's see. You go back, start from the top again. 3 and 2, come on. So, this was your original number, this was your first series. You start from this again. 4 and 3 will be compared. This is where your next series will be formed. 4 and 3 will be compared. See, what happens when I do this program on the board is I write the numbers as they are produced. But I can't do that because then I'll be doing this, then writing, then it'll break the flow. So I've pre-written it, but don't look at this right now. Okay? So far, this is where you are. Compare 4 and 3. 4 and 3, are they in the correct order? No. 4 should have been down. Interchange them. So you'll get 3 over here. This will become 4. Now you'll compare 4 and 2. Are 4 and 2 in the correct order? No. Interchange them. This is 2. This will become 4. 4 and 1, not in the correct order. Interchange them. 1. This will become 4. 4 and 5. Look here, people. 4 and 5. 4 and 5 are in the correct order. No interchanging. Leave them as it is. Are you clear? Your series is somewhat getting sorted. Second cycle over. Go back. Now, you will compare. Come on, tell me by yourself. 3 and 2, are they in the correct order? No. Interchange them. You'll get 2. This will become 3. 3 and 1, are they in the correct order? No. Interchange them. 1. This will become 3. 3 and 4, are they in the correct order? Yes. So this will remain 3. 4 and 5, are they in the correct order? Yes. This will remain 4. This will remain 5. Almost sorted. Your series is almost sorted. Go back. Now compare 2 and 1. Are they in the correct order? No. Interchange them. You'll get 1. This will become 2. You'll compare 2 and 3. Correct order. 3 and 4. Correct order. 4 and 5. Correct order. 5 will remain as it is. This is your final series. How many such series did you produce? This was your given data. 1, 2, 3, 4. In 4 such cycles, you got your result. And remember, I gave you the worst possible input. It was an entirely reverse series. So if the worst input can get sorted in 4 cycles, any input can get sorted in 4 cycles. So again, how many cycles did you require? 4, which means n-1. Your inner loop count is also n-1. Your outer loop count is also n-1. Are you clear? We will keep the inner loop and outer loop counts in R7 and R6. Focus here. R7 and R6. Both of them will be initialized with 4. Let's start. Compare first 2 numbers. Put them in a loop. So your inner loop count R6 will go on decrementing. 3, 2, 1, 0. First cycle done. R6 will become 0. Decrement R7. R7 will become 3. Go back, reinitialize R6 as well as reinitialize your pointer because R0 has gone ahead, reinitialize your pointer. So you reinitialize our inner loop count and pointer. Just don't reinitialize the outer loop count. Reinitialize the inner loop count and pointer. So R6 is 4. Do it again. First, second, third, fourth. 4 iterations. R6 again will become 0. This time R7 will become 2. Go back. Reinitialize R6. Do your 4 iterations. R6 will become 0. This time R7 will become 1. Go back. Reinitialize R6. Do your 4 iterations. When your 4 iterations are over, R6 will become 0. R7 will also become 0. Inner loop as well as outer loop count both will become 0. And your program will stop. That's when you got your final result. Are you clear? Come on, don't be scared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14-line program. Huh. You scared of a 14-line program? Really? What are you going to do? 3 things you have to initialize. Pointer, outer loop count, inner loop count. Both outer loop and inner loop counts are 4. So we'll keep both of them in R7 and R6. And your pointer R0, we'll initialize it to 20. So 3 things you have to initialize. Outer loop count, inner loop count and pointer. Initialize the outer loop count first. Initialize your outer loop count first. R7 first. Why? This will not be initialized again. The inner loop count and the pointer will be initialized when you finish your outer loop. Go back. You have to reinitialize R6. You have to reinitialize R0, the pointer. The only thing that will not be reinitialized is R7. So we'll keep R7 at the top because we will never loop back over here, but we'll loop back over here. Are you clear? So outer loop count, inner loop count and pointer. All these 3 are initialized. Tell me, did you understand this? Now, what do you want to do? Compare 2 adjacent numbers. Who is pointing to the number? R0. Take the number in A. Move A, at the rate R0. So who has got what? A has got the first number. Okay? A has. This is R0 pointing to the first number. We have taken the first number in A. Come on. Come on. Come on. Now you want to compare first number and second number. So you need to take the second number also. Increment R0. R0 is pointing to the second number. Take the second number in B. So you've taken your numbers in whom and whom? A and B. A has the first number. Come on. Come on. Come on people. Don't be scared. A has the first number. B has the second number. I took the first number from first location, second number from second location. Compare A and B. Subtraction. How do you compare? How do you compare in 8051? CJNE A, B, next. Next is next line. So we're basically not using this instruction for a jump. We are using this instruction to perform comparison. So it will compare A and B, which means it will do A minus B. A minus B means first number minus second number. You tell me. First number minus second number. For them to be in the correct order, first number must be smaller. Smaller number minus bigger number creates a carry. So if there is a carry, they are in the correct order. Skip. I have done my comparison. If there is a carry, that means A is smaller than B, which means first number is smaller than second number. That means they are in the correct order. Skip. So if there's a carry, skip, directly go to the next one. This is your label, skip. Are you clear? So if they're in the correct order, directly skip, don't do it. What is this? This is the exchange. What does the algorithm say? Compare 2 adjacent numbers. We have compared. If they are in the correct order, skip, otherwise exchange. So if they're in the correct order, directly skip, otherwise exchange. How do you exchange? This is your first location. This is your first location. This is your second location. R0 was pointing to the first location. You took the first number in A. You incremented R0. R0 is pointing to the second location. You've taken the second number in B. Your first number is in A. Your second number is in B. What do you want to do? Exchange them. So, store from A. Listen carefully. Store from A means the first number. Store from A at the location pointed by R0, which means at the second location. Store from A at the second location. Decrement R0 so that it points to the first location. Store from B at the location pointed by R0 and again increment R0. Once again, this location 20 and 21. R0 was pointing to 20. We took the data of 20 into A. We incremented R0 pointing to 21. We've taken the data into B. So your data of 20 and 21 are in A and B and your pointer R0 is at 21. Are you clear? You want to interchange them. Store the value of A at the location pointed by R1. Decrement your pointer so that it points to 20. Store the value of B at the location pointed by R0, which is now 20. Increment your pointer again so that it comes back to 21. Are you clear? Once again for the last time. Your numbers are there in A and B and your pointer R0 is pointing to the second location right now. You took your first number, incremented R0, took the second number. So R0 is pointing to the second location. What do? Store from A at the location pointed by R0. Store from A at the location pointed by R0. So you store the first number at the second location. Decrement R0 so that it points back. We are doing the only momentarily. Decrement R0 so that it points back over here. Store from B over there. Store from B to the location pointed by R0. And again increment R0 so that it points back over here. So your numbers which you have taken 5 and 4 will be reversed and stored as 4 and 5. Tell me, did you understand this? Now what? Make your inner loop. DJNZ R6. R6 was your inner loop. DJNZ R6 comma back. So when you go back, move A comma at the rate R0. You took your first two numbers, you interchange them. Your first two numbers which were 5 and 4, you interchange them. They became 4 and 5. Next time you should compare 5 and 3. And this will go on. When this inner loop breaks, you have reached over here. R6 has become 0. You will decrement R7, decrement your outer loop count and go back and reinitialize inner loop count and the pointer. Reinitialize R6 and reinitialize your pointer. When your loop breaks, go back, reinitialize R6 and reinitialize your pointer to the first location. The only thing which you will not reinitialize is R7. R7 will not be initialized again, which means your outer loop will happen 4 times. When your outer loop is also broken, the series is sorted. Say the program without looking down, without looking anywhere. Use your imagination and answer. R0 will point to the series. R6 and R7 will be your count. Whom will you initialize first? The outer count, then the inner count, and then your pointer. Are you clear? R0 is your pointer. Take the pointer's data, take the first number into A, increment the pointer, take the second number into B. Compare A and B. If there is a carry, that means first number is smaller. They are in the correct order. Skip. Do nothing. If there is no carry, that means they are in the wrong order. Interchange. What did you do? You took your numbers in A and B. Store from A to the second location. Decrement your pointer. Store from B to the first location. Increment your pointer again. So what has happened is the numbers that were taken like this will be stored in the reverse way. Are you clear? Decrement your inner loop count. Finish your inner loop. When the inner loop is broken, decrement your outer loop count. Go back and reinitialize the inner loop count and the pointer. Just don't reinitialize the outer loop count. The outer loop will make the inner loop happen again and again like a nested loop. Series after series after series, 4 times, and your series is sorted. Let's implement it. The last one, sorting. The program is already written. It's exactly the same program that we wrote on the paper. This is your series, location 20, observe. Location 20 has the value 5, 4, 3, 2, 1, 22, 24. They're in descending order, so I've taken the worst case scenario. Our program should sort it and make it ascending. So it should become 1, 2, 3, 4, 5. Okay, quick look at the program. Revise the steps for me. R7, that's your outer loop count. Inner loop count. And this is your pointer. Now, take the first number. A is equal to the first number. First number comes in A. Increment R0, it points to the second location. B is the second number. Compare first number and second number. So it is first minus second. So let's go do it as A minus B. I'm giving the comment. If there is a carry, what does that mean? It means A is smaller. which means they are in the correct order. So if A is smaller, skip. Don't do this whole exchange part at all. This entire part is exchange. Skip the whole thing if there is a carry. Otherwise, how do you do the exchange? R0 is pointing to the second location. A has the first number. Store A at the second location. We are storing A to the second location. Decrement R0. So R0 points to the first location. Now R0 is pointing to the first location, but B has the second number. So we are storing B, which is the second number, at the first location, which means we have stored them the opposite. A got the first number, B got the second number, and I'm storing A at the second location, B at the first location, which means I have inverted them, exchanged them. And again increment R0 so that it points to the second location. So this whole part that we did will only be done if there is no carry, which means when A is greater. If there is a carry, that means A is smaller, it's already in the correct order. Now, when we reach skip, make your inner loop. This will do this process again and again. When the inner loop breaks, make your outer loop, which will go back and reinitialize inner loop and your pointer, but will not initialize your outer loop count. That was a program. Save. Fingers crossed. Let us run the program. Are you ready? Focus over here. 20 to 24. These locations should get interchanged. Run. Your 5, 4, 3, 2, 1 has become 1, 2, 3, 4, 5. It has been sorted. Tell me, did you understand this? Now, this was sort in ascending. If you want to sort in descending, all you need to do is change this condition from JC to JNC. I have given that in the PDFs. For descending, simply change JC condition to JNC and you will get the same program working in descending order. You can of course test it if you want to. JC changes to JNC. Let us run. Observe, this is 1, 2, 3, 4, 5. This should become 5, 4, 3, 2, 1. Sorted in descending order. 5, 4, 3, 2, 1. All you had to do was a minor change. Your JC instruction became JNC. Okay? Run the programs, practice them, change the inputs, see whether it works in every condition or not. I hope you enjoyed this. Wish you all the best.